Why skyscrapers don't sink, the secret of foundations. Have you ever looked up at a tall skyscraper and wondered, how does that not fall over or sink into the ground? Skyscrapers reach hundreds, even thousands of feet into the sky, yet they stand strong and steady for decades. The secret? It's not just in the steel and glass you can see, it's in the powerful hidden world beneath the ground. Let's explore why these towering giants don't sink and how engineers make that possible. What are skyscrapers built on? The ground might seem solid, but it's not the same everywhere. In some places, it's hard rock. In others, it's soft soil, sand, or even clay. If you build a heavy building on soft soil without preparing the base properly, it can tilt, crack, or sink. That's why understanding the foundation is so important. A skyscraper's weight is massive. Imagine stacking thousands of elephants on top of each other. That's the kind of pressure pushing down on the ground. The job of the foundation is to spread that weight safely into the earth so nothing shifts or sinks. Shallow versus deep foundations. Engineers choose between two main types of foundations. Shallow foundations used for smaller buildings, these sit near the surface of the ground. They are wide and flat like a big shoe, spreading the weight across a large area. But skyscrapers are too heavy for shallow foundations alone. Deep foundations. For tall buildings, deep foundations are a must. Engineers dig or drill deep into the earth, sometimes hundreds of feet, until they reach a solid layer like rock or dense soil. Then they insert piles or caissons, strong columns made of concrete or steel, that anchor the building into the strong ground below. Think of it like driving the legs of a table deep into the ground so it won't tip over, no matter what happens on the surface. The role of bedrock. In many cities, skyscrapers are anchored into bedrock, a solid rock layer deep underground. Bedrock doesn't compress like soft soil. It can handle enormous weight. For example, in Manhattan, New York City, the bedrock is close to the surface in some places, which is why so many tall buildings are clustered in certain parts of the city. But what if bedrock is too deep to reach? Then engineers use a special design called a floating foundation. Floating foundations, not really floating. The name floating might sound like the building is resting on water, but that's not what it means. A floating foundation is a clever engineering trick. It's based on the idea that the weight of the building is equal to the weight of the soil that was removed to make space for it. So, in theory, the ground stays balanced, and the building doesn't sink. These are used when digging all the way to bedrock isn't practical or affordable. Preventing settlement. Even with strong foundations, buildings can still settle. A little sinking is normal over time. But if one side settles more than the other, that's a problem called differential settlement. This can crack walls, break windows, or even tilt the building. To avoid this, engineers test the soil carefully before building. Design foundations to spread the weight evenly. Use materials like reinforced concrete for strength. Monitor buildings over time and adjust if needed. 6. Famous examples. Burj Khalifa, Dubai. The world's tallest building stands on a deep foundation with over 190 steel-reinforced concrete piles, each sunk more than 50 meters into the ground. Petronas Towers, Malaysia. Built on soft limestone and clay, engineers had to carefully design a deep foundation and use special techniques to keep the towers stable. 7. The science of soil. Understanding soil is just as important as understanding steel. Engineers work with geotechnical experts who study soil types, groundwater levels, and how the ground responds to pressure. This science helps prevent disasters and saves lives and earthquakes, wind, and water. Foundations don't just hold weight. They protect buildings from nature's surprises. Earthquakes. Buildings sway, but foundations absorb and distribute shaking. Wind. Tall buildings are designed to bend slightly in strong winds. Foundations keep them grounded. Flooding or water pressure. Waterproof materials and drainage systems are added to prevent water damage or buoyancy. Rising up. 9. The invisible heroes. So next time you see a skyscraper, remember, it's not just about what's above the ground. The real strength lies below, in the carefully planned, precisely built foundation. These hidden supports are the reason why our cities can grow tall, and why the buildings don't sink, tilt, or collapse. Like and subscribe.